Okay, second announcement. Everybody has a copy of the new calendar? Everybody have one of these? Yes? No? Yes? All right. So one thing you will notice about this calendar compared to the one from the syllabus is that everything was pushed down a day. Why did everything get pushed down a day? Because of the snow day. What that means is that the date of our second test is different from what I told you on the first day of the semester. The dates for the project stuff are different from what I told you the first day of the semester. Everything gets pushed back a day, okay? Any questions on the calendar? Okay. Next thing. Okay, can we bring down the conversations? We'll get started. All right. We have finished our big section on voting. You will notice that the word voting appears on today's lesson 2. It's something called the weighted voting and the Banzhaf power index. So I will say we're going to continue to use the word voting, but it's going to mean something quite a bit different than before. So we're going to make some distinctions, even though it's still about voting. This is a really different kind of thing that we're going to be talking about. You guys should all have packet number 2. Does anybody need a copy of this? Okay, and again, the idea is that all of the information for test number 2 is in this packet right here, okay? This will take us through the second third of the course. All right, on the first page, it's something that you're going to bring with you to the test, so we're going to skip it. It shouldn't make a whole lot of sense at the moment. The back is part of that same first page. Then we get to the flow chart. You're also going to bring this with you to the test. You skip that, and then there's a blank. And we start on page 4. All right, so we will go to number 1. Not 1, 2, 3, 4. Oh, sorry, 5. Page 5. Yeah, page 4 is intentionally left blank. All right, so on page 5, we'll go up to number 1 at the top. Can we go to Johannes? Okay, can we share with each other? Anybody know anything about the Electoral College? Sam, nice and loud. Okay. Other stuff about the Electoral College? Okay, so there's 538. 538 or 438? Okay, so here as part of our government, we have senators and we have representatives, and all of them combined end up electing who? The president. We were talking like the Electoral College is used once every 4 years to elect the president. It serves no other function here in the United States. And so it has to do with how many representatives there are and how many senators there are. And it's just the way that we elect our president, which means that when you go out to the polls in November on election day, you are not directly electing the president. You can directly vote for a governor, you can directly vote for a mayor, and you can directly elect a treasurer for this classroom, but this is an indirect vote when we vote for our president. We are not directly voting. The president does not get a single vote from any single person here. The president is looking for electoral votes, this mystical 538 things sitting out there. Johannes, did you have something?
Interesting thing. This was introduced when our country was founded because we didn't really have, elections. So electors are not bound to vote. They say they are. So the reason is because when they voted back then, like all the states had their little ponies on the road, like days to the Washington, and then if something happened, like they found out that like, oh, it looks like John Adams is a rapist or something like that, then they can change their vote. But nowadays, it's kind of obsolete, so to speak.
Yeah, so how did we decide? So I'm going to pull up a web page here with a picture of the map. You guys probably can't see this in the back of the room, can you? Make this a little bit bigger. Okay, here is a map of the United States, and inside of each of these things you see a number, and that number represents the number of electoral votes that each state has. Which state has the most? California has 55 electoral votes. That 55 represents how many senators does every state have? Every state has 2 senators. Out of those 55 votes, 2 of them come from California's 2 senators. The other 53 are the representatives that California has sitting in the House of Representatives. Every state has 2 senators, but the reason California has more than, say, Massachusetts at 11 is that Massachusetts has 9 representatives in the House of Representatives. We all have 2 senators, but the population affects how many representatives you have, which affects how much power you have as we sit here coming into a presidential election.
Yeah, I find that to be an interesting dynamic because it makes sense that district is a very large state, but the original purpose of having this weight voting system was to maintain a balance between urban and rural areas. But if you look at the way that California has developed, it has gone from being a frontier state to one of the most populous and urbanized centers of the country. So it's almost like the purpose of giving it more votes is actually represented by the state's population.
Yeah, this is one of the critiques of the Electoral College from some, is that as we just heard, it was supposed to represent a balance between, you know, like city dwellers and country dwellers, and try to make it so that well said. Trying to make it so that it wasn't just the very dense city populations that controlled all the power. It wasn't supposed to be just about who has the most people in the state, because Massachusetts doesn't have very many people in our state, but we'd like to still have some representation here. And so this is one of the downsides, is does it really accurately represent all the people? Does it accurately come up with a balance between the people living in a rural part of the country versus the people living in a city? And this is one of the things that that people have talked about, whether or not it's still doing what it should be doing. Sam. Right, right. Okay, so thank you guys. That's some good contributions. Ultimately, you need to get a majority, or you need to get more than anybody else if you're going to win the election for presidency. You need a total of all of these votes to be more than anybody else. Johannes said that there are 538. If you add all of these numbers up, you get 538. Half of that is 269. And so 269 is half, but we're looking to make sure we get more than half. So 270 is the magic number. If a presidential candidate gets 270 votes, they automatically are going to have more than half, and they will win. And so when you see, you know, like come November, that magic number 270 at the bottom of the little ticker on the screen, it's because 270 represents more than half of this total right here. So a couple of things are happening. Number one, so this is what am I looking at here? This is the numbers for 2012, the coming election. Massachusetts has 11. If we go back to 2008, how many did Massachusetts have? We had 12. What happened? We lost a seat because the population changed. And what happened between 2008 and 2012 that people know that the population decreased in Massachusetts? The US Census happens every 10 years, and it happened in 2010. We'll talk a little bit about censuses later this semester, but here's visually what happens when this, like one of the effects of taking the census. It's still 538, but our 12 became an 11 and somebody else got bumped up one. And this is what happens when people move around. So you can see the blues and the reds here, and this is how the election happened back in 2008. And in 2000, what's that? Anybody notice Nebraska's? Go ahead, Henry. What does that mean? Yeah, something very strange happened in Nebraska in the 2008 election. it wasn't a half thing, but there was a split happening, and it's very unusual, and you even kind of have to look hard to see it. Um, so normally the way it works is that whatever president gets the most votes in California, the most of our votes, we go to the polls, and whoever we give most of our votes to, all 55 of California's representatives and senators decide we're going to go blue. Okay? So saying that California went blue doesn't mean that 100% of California voted blue. It means more than 50% voted blue. And by the way the Electoral College works, generally, that means the whole state goes blue, right? And so when we talk about these swing states, a state where it's kind of close, like it's like half Republican, half Democrat in terms of the people going out to vote, all you need is a little bit more than your opponent, and you get every single one of these electoral votes here. That's why the swing states are so powerful because, like, let's be honest, we're going to vote Democrat this coming election. So how much attention are we going to get from the candidates in the election months? Hardly any. There's no point. They're gonna spend their time in Florida. They're gonna spend their time in Ohio. They're gonna spend their time in places where it's kind of up for grabs because it's an all or nothing. Usually, Nebraska is not an all or nothing state. There are two states in the union that are not all or nothing: Nebraska and Maine. And so the way Nebraska has set up their votes, they have 3 congressional districts, and whoever gets the most votes, whichever candidate gets the most votes in district number 1 gets that vote, that single vote. And whoever gets the most votes in district number 2 gets that vote. And then you have these 3 things, and whoever gets the most out of these 3 gets the other 2 votes. There's a total of 5 in Nebraska. So you have 3 congressional districts voting on their own. Those votes can go to all Republican, all Democrat, or they can mix and match. The other 2 votes out of the 5 go to whoever got the most out of these 3. Okay, it turned out that Obama's camp thought that there might be a chance for a tie. There's 538 votes total. That's an even number. There could be a tie. There hasn't been, but there could be. And Obama's campaigners were worried that there might be a tie. So they went to this one state right here, which has a chance to split their vote. Massachusetts will not split our vote because it's not set up that way. But Nebraska was. And Obama campaigned really hard in one congressional district in Nebraska, and he won it. And so Obama got 1 vote out of those 5. And McCain got the other 4, but that 1 vote would have been enough to break the tie if it was going to be a tie. It turned out it wasn't all that close. Let's see, is there a total? I don't see a total. Oh, it's up on the top? Oh, thank you. Yeah. So 365 to 173. It wasn't all that close, but this is why he campaigned really hard in Nebraska. Yes, Mary.
If it's not too far afield to like what's happening today, Super Tuesday, how just win the Republican nomination, any one of those 1144 or something like that. So where were those votes? Where are those 1144?
Does anybody know? Delegates? Okay, and is that 1144 across the country? Mhm. I see. I see. Anybody else know anything?
Like how delegates are, how many you get?
I-
State and how that's calculated.
And then what they, I mean, like in Massachusetts,
Hmm?
John Kerry.
Oh, I see. So the senators end up kind of voting for the primary person.
It's also delegates who also sometimes where they go so and then also it's like how you finish their delegates can pledge
party not being or there's no guarantee that
Right, right. Good question. Okay, let's kind of wrap this up, and then we'll bring it back to some math because we haven't done any math yet. So here's the math part of this. California has 55 electoral votes. Massachusetts, well, this was old, so let's go to the current. Massachusetts currently has 11. These colors here are just the predictions based on like trends, and the swing states are the ones that are in kind of yellowish. But like this is not the result. Yeah, I can change Pennsylvania to. There we go. So this is not the results of the election that hasn't happened yet. This is just okay. So what's going on here? So California has 55. Massachusetts has 11. The question that we want to ask, and this is the fundamental question that we're asking today and Thursday, how much more powerful is California than Massachusetts? That's what I want to know. I think they should be more powerful than us. 5 times is the natural number, right? They have 5 times as many votes as us, so they're 5 times as powerful as us. Does that make sense? Yeah. Suppose that California and Massachusetts were the only 2 states. We are the only 2 states. So the only votes that are out there are 55 and 11, a total of 66 votes. Okay? If California goes for the Republican candidate, who's going to win the election? The Republican candidate, because their 55 will dwarf our 11. And if California votes Democrat, the Democrat will win. And in a very real sense, we would have no power in that system, right? If it's 55 and 11, it's not 5 times as many. They have 100% of the power. We have no say. So it's not as simple as just looking at 55 is 5 times 11. It's more involved than that. So that's what we get into today. Okay, so let's go down to number 2. And number 2, we'll go to Kelly. Okay, so let's talk about weighted voting systems, and then we'll do some nitty-gritty, simpler examples than the Electoral College. All of the elections we've been talking about until today have involved many candidates. You can vote for A or B or C or D, right? And not just vote for one of them, but do what? You rank them. You list your preference. I think B is the best, and then D, and then A, and then C. This is different. It's the same word voting, but it is a different kind of thing. When we talk about weighted voting systems, you have 2 choices. You could think of those 2 choices as being red and blue. You can think of the choices as being yes and no. Whatever they are, you have only 2 choices. And one of these 2 choices is going to win. Either red will win or blue will win. Either yes will win or no will win. That's all that there is. So there's not 4 choices anymore. There's not ranking anymore. You're either in or out, okay? And the other thing that makes this different is that it used to be that every voter had the same amount of value. Every voter had 1 vote, right? We were all equal before. We're not equal anymore. California has 55 votes and we have 11. So a couple of differences. There's only 2 options. We're not ranking anymore. And the different voters have different amounts of votes, okay? These are the things that make something called a weighted voting system. Weighted because of the different strengths of the voters. Okay, let's take a look at 3. We'll go to Iris. Okay, do we understand the setup? Because we're going to be playing with these numbers for a while. How many voters are in this company? You have 3 voters. And each voter is either going to be yes or no for whatever motion we're talking about. Maybe the motion is let's work longer Monday through Thursday and close the office on Friday. That's the question on the table. These voters are going to vote. And if enough voters say yes, then the option passes. 12 is enough to say yes. Exactly 12 is enough to say yes. It's not more than 12. It's 12 makes this thing pass, which also means 12 makes it fail as well. You can't have, like if, you couldn't have something where, you know, like it passes on the one hand and then it also fails on the other hand. Like 12 is enough to either pass it or stop it. Does that make sense? Okay, so 12 is the magic number to either make it go forward or stop it. Okay, we'll go to 4, Hillary. Sorry, Brittany. Go ahead. Okay, so a real compact way to denote that whole paragraph in number 3, you put the quota first. What was the quota? It's 12. It's how many votes you need to pass the motion or stop the motion. Then you put a colon. Then you list the number of votes that each voter has, starting with the most. What's the strongest person up here? 10. Then you put a comma, and then you put the 9, then you put a comma, and the 3. Okay? So that's how we capture all the information from number 3. Okay, we'll go to 5, and we'll go to Zach. Number 5. All right, I expect you guys can look up those words and make some sense out of them. Do you have one of these yet or no? Yeah, right there. Okay. All right, we'll go to Justin for 6.
What is a coalition? Players that get together the same way. Coalition.
Okay, sorry, Justin, one more time.
What is a coalition? Group of players that get together and vote.
Okay, let's try number 7. So coalition is just a group of people that are all going to vote yes, or they're all going to vote no. We'll just pretend they're all voting yes. And suppose you have 3 players, 3 voters, and we'll call them P1, P2, and P3. And I want to list all the ways that they can vote together. So maybe P1 is the only one that says, yes, Friday's off is a good thing. Or P2 by themselves says, yes, Friday's off is a good thing. Or P3 by themselves. But then they could also vote together in like pairs. So we could have P1 with P2. They could both think, yeah, Friday's off. What else could we have? P2 and P3. Any other pairs? P1 and P3. And what's the only other way that people can say, yeah, this is a good idea? All 3 of them. So up there we see 7 coalitions. And there are 3 players. And then P1, P2, P3 is another option, but these are 7 different options. 1, 2, 3, 4, 5, 6, 7. Okay? 7 coalitions. 7 ways that these folks can either say, yeah, that's a good idea, or no, I'm opposed. Okay, so what if we had more people? Well, if you had a 4th person, then you'd have more coalitions. If you had 5 people, you'd have a lot of coalitions, right? It turns out there's a nifty little formula that I think you might see in your book about the number of coalitions. Coalitions. And the formula is this. It's 2 raised to the number of players, subtract 1. Always subtract 1. For example, how many players did we have in this example here? We had 3. So if I do 2 to the 3, subtract 1, how much is 2 to the 3? That's 8, and then subtract 1, it's 7. The 7 that we listed out there. Any questions on the formula? You guys, can you answer this one? If there are 5 players, how many coalitions are there? Just check with your neighbors. You don't need to say it out loud, but just look into that formula and check with your neighbors. How much is 2 to the 5th? 32, right? We do 2 to the number of players. So 2 to the 5, subtract 1. 32, subtract 1, 31. If you have 5 people, there are 31 different ways that they can be in favor or opposed. Can we try this real quick? All right, the only table I see here with 5 people is this one. You're included. Okay, so let's think about 31 ways. We're not going to do all 31, but we just want to get a sense of what the 31 ways are. We're going to have people stand up if they're in favor of the motion, okay? Can you stand up? This is one coalition. Maggie's the only one in favor. Have a seat. Stand up. This is a second coalition where Becca is the only one in favor. Have a seat. Stand up. That's third one. Stand up. Philip, stand up. That's fourth. And stand up. Amy is a fifth coalition. Yes, that's 5. That's all the single coalitions. What kind of coalitions can I do next? We can do pairs. That's 1. Have a seat. You're still up. That's 2. Have a seat. That's 3. Have a seat. That's 4. Maggie's done. Now you're up, and you're up. That's 5. Wait, was that 5 or 6? That was 5. Up, and then 6, and then 7. Those are all the pairs. Let's keep going with that. Those are the pairs. What's next? Now we have trios. That's 1 trio. Have a seat. That's another trio. Have a seat. That's another trio. Have a seat. You're down. You're up. You're up. That's another trio. Good. Have a seat. What's next? It's quads. Okay, I'm not going to get these people standing up anymore, but we get the sense that there's a lot, right? A lot of ways these folks can band together and say, yes, Fridays off is a great idea. I'm voting yes. Turns out there are exactly 31 different ways they can stand up. Fair enough? Okay, number 9, we'll go to Hillary. Okay, you'll look that stuff up. Critical player is the most critical phrase in that list. We're going to do it together here. I'm not going to write down the definition, but we'll see that phrase over and over again for the rest of this class. Okay, we'll go to 10. Ashley. Number 10. Okay, so right now we're just going to kind of list a bunch of data about these 3 people in this weighted voting system. And the ultimate goal is to come up with a sense of how much power each of these people have. Does the 10 have like 60% of the power, and the 9 has 30% of the power, and the 3 has the other 10%? That's what we're after, right? There's 100% of power up there somewhere. We just want to figure out how it's really divvied up. And this is our first step towards that. We're going to list all the coalitions. It's the same as the ones that we listed up above. P1 by himself, P2 by herself, P3 by herself. And we have the pairs. Same list as up above. And once we finish the pairs, what's left? That's all of them together. And now what we're after is the weight. How much weight did these coalitions have? Okay, so remember, P1 is the very first person. P1 has 10 votes by himself. So the weight of this coalition right here is 10. P2, what's the weight there? That's just 9. P3? Just 3. Now we get into the pairs, and all we have to do is add the votes together. P1 and P2. Total, they have 19. Can you guys fill in the rest of that column? Okay, what's the next one? So for me it's 13, and then the next one is 12, but that's okay if they're in a different order for you. And then the last one, 22. Okay, then we need to decide if these coalitions are winning or not. Remember, winning means at least 12. 12 or more is winning. Is this first coalition winning? No. Next coalition? No. Next coalition? No. 19?
Yeah.
Finally, that's enough. Anything 12 or more wins. Henry, can you put that away? 13 is enough. How about 12? 12 is enough. Make sure you're clear on that distinction. Quota is enough to pass the motion. So exactly 12 is fine. 22, plenty. All of this is pretty straightforward. Now we get to the hard part, the part where we really have to do some analysis. We're going to get into this idea of a critical player. So I'm not going to write the definition, but I'll say it a bunch of times today. First of all, critical players only apply to winning coalitions. So nothing is happening for those first 3. And in fact, every time we do examples in the future, we're not even going to bother listing the losing coalitions. We don't care about them. But we look at the winning coalitions. We ask ourselves the following question. Suppose we're looking at P1 in this coalition right here. I want to know if P1 is critical, if P1 is important in this coalition. And a bunch of people are saying yes. So we temporarily say, what if we crossed off the P1? How many votes does this coalition have left? Only 9. Is that enough for it still to be winning? No. So P1 is critical to the success of that coalition. If you lose P1, you lose the coalition. It doesn't win anymore. So we say, yeah, P1 is really important. P1 is critical. And the same idea, P2 is critical because if you cross off P2, you've just lost 9 votes. You have only 10 left. That's not enough. So P2 is critical. Can you guys fill in the rest of that column? This is the tough part. So check with your neighbors as you fill it in. See if you agree or disagree. Justin? I won't say it doesn't exist because there's only one. I'll say it doesn't exist because the coalition doesn't even win to start with. Like, to be critical means you have to be winning already. Yeah. Okay, so see if you guys can check with your neighbors. Lots of chat about that column. It seems like we have lots of agreement that everybody's critical. And then the only question is what happens when we get to that last row. So in this last row, what happens? If you cross off P1, how many votes do they still have? They still have 12. Do they still win? They do. Was P1 critical to the success of this coalition? No, they could do without P1. They still win. Now P1 is back. It's a very temporary thing when you look at a player, okay? P1 is back in. Sometimes people say, okay, cross off P1 and then cross off P2 and all of a sudden somebody becomes critical. You're never crossing off 2. You're only crossing off 1 at a time, then you bring them back. So let's look at P2. If you get rid of P2, how many votes do the first and third people have? 13. That's enough. Is P2 critical? No. P3? No. Nobody's critical down here.
So wouldn't this be a scenario where, in order for an individual you would have to have some types of dictator?
It's a good question. So we haven't defined dictator, but it's in your reading, and you'll take a look at it. I don't think that, I think if you say everything you said, but change from dictator to somebody with veto power, then like it's a person with veto power is the only way that they would come up down here. Yeah, so we'll see examples of that. Okay, so we're going to analyze this in one last step, but before we do, another one of your classmates has given you a poll to fill out, so can you take a moment to rank these things, and then we'll move on. Okay, so let's bring this example right here to a conclusion. How many times was P1 critical on the right-hand column? It's twice, right? So what we're going to do is we're going to count number of times each player is critical. And we've just figured out that P1 is critical twice. How many times does P2 show up on the right-hand side? Also twice. P2 is critical twice. And P3? Twice. This should be surprising. How does it appear power is distributed from these three people? It appears to be equal. You buy it? Every player was critical, was really important, exactly the same number of times. So that 10 and the 9 and the 3, which kind of like misled us into thinking the 10 and the 9 had almost all of the power. Not true. The 3 has exactly the same amount of power as the 10 and as the 9 because they're all important the same number of times. And so the last thing we do, because I had said I want to get a percentage. I want to know, is it 50% and 30% and 20%? I want something where 100% of the power is distributed. What you do is you take these guys and you divide them. Do you know what you're going to divide by? Not 3.
0.
We're going to divide by 6. The reason we divide by 6 is because 2 plus 2 plus 2, 6. Okay. So we divide by 6. And 2/6 is something you can think of as a percentage. What percentage is 2/6? It's 1/3. It's about 33%. And in fact, they all have 33%. Okay, so the last step here, count the number of times each player is critical, add them all up. In this case, 2 plus 2 plus 2 was 6 appearances of critical players. Divide everybody by 6. That's how you get your fractions or percentages. So every player here has 33 1/3% of the power. Questions on that example? On the next page, we'll go to Sam to read through that procedure.
We now define A, make a list of all songs. B, find D, here's one on right. Then divide that by the total group.
All right, that's the step-by-step process. It's the process we just did. So let's see if we can do it one more time for this weighted voting system. By the way, Bonzoff is the person's name, the person who came up with this idea. So let's try it for this weighted voting system. We have 10 is the quota. How many players are there?
4.
There are 4 players, a 6, a 5, a 4, and a 2. Let's start with this idea of the, do you remember the 2 to the n minus 1? N is the number of players. So how much is n? So yeah. So if you do that calculation, there's 15 somethings. 15 whats? Coalitions. Yeah. If you were to list all of the coalitions, you would list 15 things. On the previous page, we listed 7 things. There were 7 rows in that big table that we made. So in theory, we should have to list all 15. But in practice, you don't. And this gets back to the question Justin had asked about. Which coalitions are the only ones we care about? The winning ones. If you're in a losing coalition, well, you're not critical because you didn't win in the first place. So the only ones that we care about are not all 15, but just the winning ones. So let's go ahead and, what's that? Yeah, so we're gonna save some time here and just start removing the ones that are losing. So I'm gonna label them P1, P2, P3, and P4 in that order. Those are the names of my 4 voters, 4 players. And then I'm just gonna start by listing the winning coalitions. Are there any single people that are winning coalitions? No. If there is a single person, what are they called? That's a dictator. If it's a dictatorship, this is a very easy thing to calculate. How much power does the dictator have? 100%. There's nothing to do. So no single people have enough power. Let's look at pairs. So singles, none. Now we'll look at pairs. P1 and P2, is that enough to pass this thing? Yeah, so P1 and P2. I'm going to go ahead and add them up just so I've got the number here in front of me. So P1 plus P2 is 11, just so we see it's 10 or more, so that's good. How about P1 and P3? P1 and P3, that's 10, that's just enough. How about P1 and P4? Yeah, P1 and P4, it's not enough. It's only 8 votes. We need to get at least 10. Okay, then we'll go to P2 and P3. Is that enough? No. P2 and P4? No. P3 and P4? No. So take your time as you come up with some way, like some systematic way to just churn through all these, but only list the ones that are winning. After we have pairs, we go to trios. Okay, so we got P1, P2, P3. If we add them all up, what do we get? 15, is that enough? Yeah, that's good. Then we have P1, P2, and P4. How much is that? That's 13. And then there's one that's really easy to forget. And it's at this moment that it's really easy to forget. But there's another trio with P1. It's P1, 3, and 4. If you're going to skip a trio, I can just about guarantee you it's going to be that one. How many votes do they have total? That's 12. And then I think there's one more trio. That's P2, P3, and P4. And that's 11. Okay, so all the trios are winning. And then what's the last group to put up here? It's the only quad. In your book, you'll see this is called the Grand Coalition, everybody. P1, P2, P3, and P4. And how much do they have total? What is it? 17? Thank you. Okay, I don't want to take anything away from this part of the process. You have to be really careful to make sure you list every single, every pair, every trio, every quad. You can make your life a little bit easier if you recognize that on the first page, it does have a list of all the coalitions with 3 players. We listed those 7 things in the last example we did. Here's all the coalitions with 4 players. We didn't bother listing the singles because they all lost, but there are all the pairs. How come we don't have as many pairs that we just wrote down? Yeah, some of them didn't win, but at least you could have this in front of you and like know that you have a list of everything and then just grab the ones that win. And here are all the trios. Oh, oh. No, it did not. So there are all the trios, including the one that it's everybody's favorite one to forget, P1, P3, and P4, and then finally the single quad, okay? So have this in front of you as you're doing the homework. Okay, so we are here. Okay, so next thing to do is this critical question. So we look at each player, we decide if removing them turns the coalition from winning to losing. So if we get rid of P1 in this very first pair, how many votes did we just lose? We just lost 6, which brings us down to something under 10. 10 is the magic number. We're just discovering all kinds of things today, aren't we? Yeah, this so this is the magnifying glass. We haven't really had a chance to. There you can really focus in on stuff. There, that's a P. Okay, so let's try that again. So we were looking for 10, and if you get rid of P1, then you're under 10. So P1 is critical. How about P2? If you cross off P2, you just lost 5. Yeah. I mean, like if we, yeah, these guys, like they barely win, right? I mean, like 11 and 10 is just barely winning. So cross off any of them and we're in trouble. So over here, I'm listing my critical players. And we figured P1 and P2 are both critical. P1 and P3 are both critical there. And then we get to the more interesting, the trios, where we actually have to kind of think about stuff. So if we cross off P1 in that trio, is there enough power there to still win? And vote for no. Everybody see what we're calculating? Cross off P1, P2 and P3, 5 and 4, that's 9. Not quite enough. So P1 is critical. Play the same game crossing off P2. P1 and P3, do they win? They do. Is P1 critical? Nope. Because they could do without. Cross off P2, P1 and 3, it's 10 votes. That's just enough. One little shortcut. If you cross off P2, what's left? It's P1 and P3, right? Do you see P1 and P3 in this winning list up above? Yeah. So crossing off P2, does it still win? Sure. I listed it. It's right there. So you don't even need to do the arithmetic. If you just look up above, is it up above? Oh, okay. Well, then it still wins. So then would that have worked when we tried crossing off P1? Is P2, P3 up above? P2, P3? It's not up there. What does that mean about P1? It's important. Okay. What if we try crossing off P3? It's up there. It still wins. P3 is not critical. Let's come down here to this P1, P2, and P4. If we cross off P1, it loses. So P1 is critical. If we cross off P2, P1, P4, it loses. So P2 is critical. If we cross off P4, not critical, because P1, P2 still wins. They're right up there. So we're done with that list. And we're working our way through. If we cross off P1, then the P1 is critical. How about P3? Yeah, P3 is critical because P1, P4 is not there. And then finally P4. Yeah, P1, P3 is still winning. See it up above. Now I recognize as we finish our calculations, like we're doing this quick for like if you've never seen this kind of calculation before, it's quick. So don't feel like you need to go as fast. Don't feel like you need to use this little shortcut of looking up above. I'm just trying to get to a point where we can get an answer for this thing. But I'm hoping that we're in a place where we could do this, even if it's at our own pace. So let's just write down the answers for P2, P3, and P4. I feel like they're all critical. And this kind of makes sense because 11 is barely enough to win, right? Like you needed 10. So 11 doesn't have a whole lot of wiggle room. If you lose anybody, you're going to get down below 10. So everybody's important there. And in this last coalition, if you lose somebody, like P1, P1's not critical because you can do without, right? Every single trio is up here. So you could lose anybody and still be okay. So who's critical in the last one? No one. We've done the hard part. We just need to bring it together and get our percentages. So we're just going to count again how many times each player appears in our critical list. So very carefully counting, how many times do we see P1? I count 5. All right. Okay, so P1 is critical exactly 5 times. P2, I heard a 3 and I heard a 4. Which one is it? 3, right? P2 is there 3 times. P3, I think that was also 3. And P4, just the once. Only important in that one single coalition at the bottom. Now, I'm going to give you a test question similar to this one in like a month. And I guarantee you, some of you are going to forget to divide. Even though I'm begging you at this moment to not forget to divide, this is a power distribution. We want percentages. To say somebody has a power of 5 doesn't mean anything to me. To say somebody has a power of 20%, okay, I can do something with that. But 5 is meaningless without the denominator. So how do we figure out what goes downstairs? You add them all up. 5 plus 3 plus 3 plus 1. How much is that? That's 12. Everybody gets divided by 12. So it turns out P1 has 5/12 of the power, a little less than half. P2 and P3 turn out to be tied. They both have 25% of the power, which is kind of weird because they didn't have the same number of votes, right? But it turns out that that extra vote going from 4 to 5 is worth nothing. So if you were P2 and P3 offered you like $100 for a vote, what would you do? If you were P2 and you were offered $100 by P3 for one vote, would you sell for $100? Sure. What is that vote worth to you? Absolutely nothing. You have 25% of the power with that vote and without. So sell it. Okay, questions on this? Sam? No. All right. So I want to make sure you guys have a chance to do the group activity, which is on the next page. But we'll just jump down here to 14 for a second. Blake, 14. Okay, so we'll see software next time that will do this for us very quickly. In terms of the projects, again, we had a couple of people do surveys in this class that you guys have completed. Somebody turned in a finished project today. So some folks are working on it. It's okay if you haven't started, but you really should be thinking about plan. So I'll say this, the pushing everything down a day made it so that the plan is now due the class when we come back from spring break. I'd really encourage you to turn in something to me on Thursday, just to show me you're thinking about one of these projects and that you've done just a little bit of work in terms of finding maybe a source or two. And that gives you some time over break if you're available to really kind of churn through and do the bulk of this project if you're able, okay? These are my deadlines. These are my official deadlines. I'm not changing them to anything earlier. but I'm just putting it out there that I'd encourage you to spend some time over break looking at the project. The plan is just a one paragraph thing that says I'm going to choose this project, and you know, like if it's a poll, here's who I'm going to poll, or if it's a paper, I've found this book online, and I'm just going to go to the library and pick it up. Just something small to let me know you're thinking and you're focused on a project. Okay. All right, we have 15 minutes. Can you guys see what you can do on this frontier power example?